Hello everyone, I am S.J.C.Sandaruwan. Today I am going to present about why and how to use drones in construction and infrastructure. Drones are mainly used in construction and infrastructure for surveying and inspection purposes, with drones making it easier and easier for companies to provide visual data on the progress of a construction project. These updates include detailed maps of entire site with GPS points, which allow you to zoom in and view small details of the area. Let's see common applications of drone: agricultural application, terrain mapping, aerial photography, shipping and delivery, disaster management, wildlife monitoring, weather forecast, entertainment, and military uses. How drone used in construction industry: mainly used for surveying and inspection purposes, also topographic mapping and land surveys, equipment tracking, remote monitoring and progress reports, personal safety and equipment safety, structure inspection and photography. Sensor systems in inspection drones: LiDAR, RGB or CMR systems, multispectral and hyperspectral, thermal, ground penetrating radar, optical gas imaging, emerging sensor technologies. You can see the respective figures of LiDAR, RGB and thermal on the right hand side. LiDAR, method for determining ranges by targeting an object or a surface with a laser and measuring the time for the reflected light to return to the receiver. RGB. RGB is an additive color model, while CMYK is subtractive. RGB uses white as a combination of all primary colors and black as the absence of light. CMYK, on the other hand, uses white as a natural color of the print background and black as a combination of colored inks. Thermal. Thermal sensors are used for gathering data from subjects' thermal emission. Drone data used in the construction industry. Drones are equipped with downward-facing sensors such as RGB, multispectral, thermal or LiDAR, and they can capture great deal of aerial data in a short time. Photograph multiple times from different angles, and each image is tagged with coordinates. Taking the technology a step further, photogrammetry software can combine the images to generate georeference 2D maps, elevation and 3D models. These maps can be used to extract information such as precise distances, surfaces, and volumetric measurements. Large infrastructure such as roads, railways, bridges, dams, water reservoirs, airports, industrial complexes, oil and gas operations, and power complexes have considerable potential to use drone data to optimize their operations. The complexity and scale of such projects exposes them to many challenges this technology can help solve, including long and costly surveys, early identification of construction mistakes, penalties for missing deadlines, miscommunication between stakeholders and contractors, and volumetric assessment. It can also help stakeholders efficiently survey to avoid financial liabilities post-construction due to lack of maintenance and resultant damage to the environment. Drones can also open up new applications that were previously very hard or costly to access or closely track. Think of monitoring or inspecting hard to reach areas, or of analyzing and optimizing rapidly changing environments such as construction sites. Benefits of using drones for construction. First one, fast, reproducible, on-demand image acquisition. Drones provide a complete picture of the construction sites on demand and within a few hours. The sharp, detailed images produced by drones enable site managers to track work progress and make accurate decisions. Accurate and comprehensive data provides a complete map of the site with GPS points in 2D and 3D. These maps allow accurate measurements of distances, surfaces, elevation, and volumes. Also, cost and time saving. Significantly reduce time intensive data collection in the field and its associated labor costs. Take the fly for half an hour, process data, and get the same or better result than ordinary way. Better documentation. Drone data provides a clear, accurate, and retrievable documentation at frequent points in the construction process. Remote access to current status of the site. By having somebody on site flying the drone and capturing images, you will be able to see the progress of projects directly on the computer, to evaluate it and discuss it with site managers as if you were in the site. Increase safety. Monitor and inspect hard to reach places or areas in the middle of machinery without entering them. Obviously reduce workers' exposures to accidents. Drone application throughout the construction cycle. bidding and pre-planning. Even before the launch of many construction projects, a topographic survey of the site is required to get a good understanding of the environment in which the projects will take place. DTMs and DSMs of site generated drone data can show possible drainage points, changes in elevation, and other factors that can assist in selecting the best location for building, digging, or storing materials. Planning and design. Assess how the new projects will impact the area from both the practical and the aesthetic viewpoint. 3D models also allow analysis and visualization of cast shadows and outlook views. At the execution stage, you can get the precise volumetric measurements with the photogrammetric software and also as-built drawings. Accurate site visualization is the ability to overlay the CAD on the orthophoto. Also site progress monitoring by drone. You can see the figures which shows how drone engage in construction activities. Maintenance and asset inspection. By sending drones in the air, companies can visually inspect large assets or those located in hard-to-reach areas more quickly and cost-effectively. The picture shows a dam inspection. Applications of GIS in construction. GIS technologies have the potential to solve space-related problems of construction planning and management involving integration of information, urban planning, project site selection, soil studies, hydrology and environmental studies. References. Thank you all for joining my presentation.